polynomial of degree n for each. So we're gonna do 5 questions here, and start with problem 9. F of x equals to e raised to the power of negative 2x. At the same time, we are asked to find the third degree for the Maclaurin polynomial. So we start with, just recall Maclaurin polynomial. It's written as n of x equals to sigma lower bound with n equals 0 goes to an upper bound infinity, and f m prime of 0 divided by n factorial. So question 9 asking us about the third degree of f of x raised to power equal f of x equals to e raised to the power of negative 2x. So we're going to solve the third degree of derivative of the function. So we start with first derivative, f prime of x equals to negative 2 e raised to the power of negative 2x. Then we solve the second derivative. It goes to 4 times e raised to the power of negative 2x, and the third degree of prime of x, it goes to negative 8 e raised to the power of negative 2x. And we plug in with zeros. That's a definition for Maclaurin polynomial. So f prime of 0, f of 0 equals to 1, f prime of 0 equals to negative 2, f double prime of 0 equals to 4, f third prime of 0 equals to negative 8. Yeah, that's it. And then that's all we need to find the Maclaurin polynomial, the number, the coefficients. So let's start with the polynomial. So the first term, m3 of x equals to 1 minus 2 times x raised to the power of 1. It can be ignored. Divided by 1 factorial, and plus 4 times x squared divided by 2 factorial, and minus 8 times x cubed divided by 3 factorial. Let's see question 10. F of x equals to 1 over x plus 1. So we can just make it to x plus 1 raised to the power of negative 1. So first prime, f prime of x equals to negative x plus 1 raised to negative 2 of power. And of double prime goes to 2 times x plus 1 raised to the power of negative 3. And f third prime equals to negative 6 times x plus 1 goes to negative 4, and f fourth prime of x equals to 24 x plus 1 raised to the power of negative 5. Then we start with f0, it goes to 1. Then we start with f prime of 0, it goes to negative 1. We start with f double prime of 0, goes to 2, f third prime of 0 goes to negative 6, f fourth prime of 0 goes to 24. Then we start Maclaurin polynomial, which is m4 of x equals to 1 minus x plus 2x squared divided by 2 factorial, minus 6x cubed divided by 3 factorial, and plus 24 times x raised to the power of 4 divided by 4 factorial. And notice that you don't have to simplify during the AP exam for Tyler or Maclaurin series or polynomial, because that's a policy. You don't have to simplify that. You don't have to simplify that. That's it. Let's say question 11. F of x equals to natural log of x plus 1, and degree is 4. So f prime of x goes to 1 over x plus 1. So it's equals to x plus 1 raised to the power of negative 1. F double prime of x goes to negative x plus 1 raised to the power of negative 2. F third prime of x goes to 2 times x plus 1 raised to the power of negative third, negative 3, and f 4 prime of x equals to negative 6 times x plus 1 raised to the power of negative 4. And f0 equals to 0. F prime of 0 equals to 1. F double prime of 0 equals to negative 1. F third prime of 0 equals to 2. F fourth prime of 0 equals to negative 6. So Maclaurin series for this, for natural log of x plus 1 by degree of 4 equals m4 of x equals to equals to 0 plus x minus x squared divided by 2 factorial, and plus 2x cubed divided by 3x factorial, and minus 6x fourth divided by 4 factorial. Yeah. And let's see, 12. So f of x equals to sine 2x and equals to 3. So f prime of x equals to 2 cosine of 2x. F double prime of x equals to negative 4 sine 2x. And f third prime of x equals to negative 8 cosine 2x. And f0 equals to 0. F prime of 0 equals to 2. F double prime of 0 equals to 0 again. And f third prime of 0 goes to negative 8. So Maclaurin series for f of x equals to sine 2x by degree of 3 equals to m3x equals to 0 plus 2x plus 0 minus 8x cubed divided by 3 factorial. And that's it. And question 13, use your answer from question 11, which is ln x plus 1 to approximate f 0.1. So f 0.1 equals to ln 0.1 plus 1 equals to ln 1.1. So just plug to the calculator and you will get the number. It's here, which is m4 of 0.1, which is a fourth degree from the function, from the Maclaurin polynomial. For the 0.1, the value we need equals to 0.095308. So that's a Maclaurin polynomial practice set today, and we're probably gonna do some tighter series in a few hours, and I'll also upload the video. Hope you guys learned something from it. See you next video.